All right, so this is week 1 of Foundations of Software Development. And in this course, what we aim to talk about is everything that makes you a good software developer, from data structures to algorithm. Now, for you to build softwares, you need to understand how to optimize your code such that whenever you have a task or a user or a function, it does not take time or slow down the performance of the system. Whenever you have big data, the way that this data is stored and retrieved is optimized to the maximum so that you don't have problems in your end product. So this course basically teaches you all of those foundations on how to think like a developer to solve problems. And everything you find in this course is what you typically find in technical interviews to get any of those high-paying software development jobs. Without this data structure and algorithm knowledge, all of the sorting algorithms and searching algorithms, you will almost always fail a technical interview. All right, so when we talk about data structure, we mean finding efficient ways for us to store data and to retrieve the data. The way and the format in which you store this data for different purposes is the data structure. Now, in our examples that we always give, we say that we can see data structure almost anywhere. If you come to any family, there's already a data structure in the family. It's like a tree. You'll see the father, the mother, you see the children as branches, and then the children have children as branches, and they have other children, and then it branches out to they get married to another family, and that family have their own branch, and so you see the whole tree. So if I want to get from person A I want to see the lineage of a child, I can trace it through the tree, and I can look for the shortest path that takes me from the origin of the person to where the person is. So I won't want to go through the mother, the father, the elder brother's family and keep turning around. I'll just know exactly what branch, so the shortest path. Another example is when you have GPS, for instance. Sometimes when you are using GPS on the navigation on the road, it always calculates the shortest path instantly to tell you that this route is shorter than that route. You can go here, you save 10 minutes. You can take this route, you take 10 minutes. So these are the algorithms used in building things like GPS, right? Data structure. So you find examples, especially in the assignments that we have weekly, are going to be exactly the same, simulating interview questions. And when you are able to sit down and think and solve those assignments that we have weekly, I can almost promise you that you're going to land yourself a high-paying software development job. And at the end, you'll be able to think like a developer. So we have 2 types of data structures. We have the primitive one, which are the ones that we have provided with the programming language, and then we have the abstract ones, which are the ones we're going to look at. They are more specialized, like the arrays, the linked lists, the stacks, the queues, the trees, and the graphs. Then, whenever we have a problem, we want to think through it in the language you understand the most, not a programming language. If I'm thinking through it in English, and English is my first language, I can think and write out the steps I want to do. Just like you want to have your Saturday to-do list. You want to organize what you have to do on a list so that you know how to start and end and have your day organized. So even if you're tired, you just follow your list and see what you've done. Or you want to maybe cook something, you have the recipe, you see step-by-step instructions, what you have to mix first before something else. Those are algorithms. If English is not your first language, you want to think about these things in the language that you understand the most. And I'll tell you why you do that. Because sometimes certain things are more understandable in your language. So when you're asked the question, you want to translate it in your language in your head. Think about it thoroughly and then put it down in the language and everybody understands, and then now try translating it in English. or in a programming language. In the pre-recorded videos, we use the Fibonacci sequence, which is something that they'll use to test your problem-solving skill. You can see a question like 1, or type, they might just tell you 1, 1, 2, 3, 5, 8, and tell you to fill in the next 5 numbers. Now, in that problem-solving example or in that technical interview, you will not be told that this is the Fibonacci sequence, but expect that when you understand data structure and algorithm, looking at this, you'll be able to problem solve to the point where you say, this is, I add this to, I get this. I add this to, I get this. Or then you continue the pattern. And that's what the Fibonacci algorithm is, where every number is gotten by adding the 2 preceding numbers. So how do you code this in the programming language? So what we know is that we start with the first 2 numbers, and the first 2 numbers is always 0 and 1. And then we add those 2 numbers to get the third number. We update what the first 2 number is now to be the second and the third to get the fourth, and continue like that for the number of times you want. So if you want 50 Fibonacci number, the first 50 Fibonacci numbers, you want to do it or to get the first 50. So we know what it is, we know the algorithm. So how do we implement this? So we want to start by saying, let's say we create a function to make it easy. And this function, let's call it function sequence. We want the user of this function to be able to pass in the number of sequence the person wants. You might want to check. So as a developer, one thing you do is when you receive an input, you want to sanitize the input, right? And part of sanitizing the input is looking at checks. Do you want the inputs to be only integers? You want to check if it's an integer. Do you want it to be to start from a particular number? You check that condition if it's true before you go into the body of the execution of that task. And the reason you have to check is that when you do this in software, you're going to have a lot of system crash. So let's say, for instance, if you want the input to be a number and the person put a string, and then without the check, it goes straight to try to iterate through the string and it tries to add or subtract or do something. What now happens is your system will fail, or you start having errors that crash the system because where it did not stop the execution once an unexpected input is met. There was no error handling. So for the purpose of this lesson, we're not going to put all of those error handling methods, but we're just going to go through executing the task. And when we get to the full stack software development course, we'll see where we do all of those checks and type verification. So the first thing you want to look at, and one of the most reasonable check you want to check here, is if the number passed in by the user is less than or equal to 0, you want to return an empty list. But if it's not less than or equal to 0, then you want to start the sequence. The idea is that you want to have 2 numbers that are the first numbers to initialize, and the first 2 numbers are 0 and 1 for a Fibonacci sequence. And so how do we want to initialize this number? We want to say A is equal to 0 and want to say B is equal to 1. Now you can write this in one line. AB is equal to 0, 1, like this. So it makes it neater, right? So we have the first 2 number, A is 0, B is 1. We want to loop through the total number that is specified in N. So because when the user say N is 20, you want to loop through all of the 20 sequence, right? You want to create a sequence of 20 numbers. We looked at, in our Python course, the range function where we use to generate sequences starting from 0 to the number specified. right? Or 1 less than the number because it starts from 0. So one thing you want to remember in programming is that in most programming language, if not all, counting starts from 0. So if you have a list of length 5, the last index position is going to be 4. 1 because 0 is the first index position, 1 is the second, 2 is the third, 3 is the fourth, 4 is the 5. So whenever you use the len function to get the length of an array or a list, you're going to get 1 more than the last index position. Does anybody understand what I'm saying? Do you all understand? I'm not hearing anyone.
Yes.
Yes.
So you get 1 more than the last index position when you use length or the range. So we have something sometimes you see in programming, and I want you to know most of the things you see so you don't get confused when you see them. When I say 4 underscore in range n, what I mean here is this is a throwaway variable, right? Because we don't need the iterator for anything. We just need it to iterate through the total number we want in the sequence and just append the number somewhere, but we don't need to use it for anything. We have the list method append. Now in Python, we do not officially have arrays, so we use list and any of the sequence type as an array for Python. And when we get to JavaScript or PHP, you'll see the full definition of arrays. But in Python, we use a list as an array. We want to iterate through the range of values. And when we iterate through these values, we want to append something to a list. And for us to append something, we want to create that list, which means that outside of this, we want to first of all create a list. Let's call the list fib sequence into an empty list. So when we iterate through here, the first thing we want to do is to append the value of a, which is 0, because we want the first one to be 0. You can go ahead to think about your algorithm in a different way and append 1, but then it will not make sense for the iteration we want to do. The algorithm says that you always start with 0 and 1, and then you get the next number by adding the 2 preceding numbers. The 2 preceding numbers will always be 0 and 1. And when you add 0 and 1, you get 1 for the third one. So we want this algorithm to start the calculation after the first number. So what do? We append the value of a, which is 0, to the list that we want to return, and then we update the value of a. So a will be equal to b, which is going to be 1. And b now will assume the value of a plus b. So I'll explain this again so you understand. A is equal to b. So we're just saying we're updating a. Once we append the value of a to the sequence, we no longer need the 0 value anymore. We want to now update the value of a. So every time we are iterating through, we want a and b to remain the last 2 numbers. The last 2 numbers will always be a and b, which means we always want to update their values once we append. So you append a, you assign a to be equal to the value of b, which is 1, and b will now be the value of a and b together, a plus b, which will be 0 plus 1. And then you want to do this in a loop, so it will keep doing that until it reaches the final number that the user specified. And at the end of it all, you want to return the list that you have. Does everyone understand the way we think about this? Now you will be able to think about this in a different way or implement this differently, but you want to think about an algorithm that is optimized. Do you all understand this?
Yes.
Okay. So let's do such that the user is going to enter the number of terms that they want to print out, and then we are going to run that through the sequence. So I'm going to run this, and it says enter the number of terms. Let me say 40, and then it prints out the first 40 Fibonacci sequence like this. Okay, so when you ask you what is the 10th number in the Fibonacci sequence, you know it. So this is a very popular thing that you always meet for maybe entry level or the first stage of an interview. But there are another way you can do this. You can solve this by recursion, which will not make sense because you call a function within itself. But every time you put an algorithm, you want to ask yourself, does it repeat a process? Is it heavy on execution? What is the shortest way? Complexity doesn't always mean it is the best, because we have that misconception in software engineering. When you see a senior engineer who writes some complex code, it looks like one-line complexity. An junior engineer will spell it out like this. And at the end of the day, the junior engineers will make more sense in terms of execution time than what the senior engineer writes, because it's all about fanciful, looking beautiful, but it's complicated. And as complicated as it is to the human eye, it will be complicated to the processes or the interpreter that is involved. So you have to do away with unnecessary complexity and stick to the simpler it is, the better. But while it is simple, you want to make sure you are not repeating a process or what's the best way to optimize. Okay, we can use generators and we yield instead of using return statement like this or yield. But when we get to network programming course, you'll see where the yield is more useful than using generator is more useful than returning a function like this. So this is just a simple example where you pass in a number and then you use that number to execute something. In our assignment, the last number in the assignment, you have a question that says that, let me get the assignment file. Question 3 of the assignment says we should create an array of unique numbers that sums up to 0 using an integer argument. So when you supply an argument in this array, you want it to sum up to 0. So who can tell me now, when you think about that question, what's the first thing you think about? Anybody? I can't hear you, Edmund. It's okay. I can't hear you. Your voice is mumbled if you're using a headpiece.
Okay, can you hear me, ma?
Yes.
Okay, I was saying if you could go through the question again.
So the question in assignment, in the last number 3 of the assignment, and the assignment is due, is already close to the due date. Our assignments are going to be high impact and we submit every week. And so there's no extension of deadline. We need to simulate real world and you need to be able to think fast. The question says that you create an integer, create an array of unique numbers that sums up to 0 using only integer argument. How will you think about this as a problem solver? I think the assignment is due on Monday. And does anybody just guess? There's no right or wrong answer. Just your thought process. What's the first thing you think about? Peniel?
Can you repeat it one more time, please? I didn't get that. Got a little distracted.
Okay. So I said that when you say create an array of unique numbers that sums up to 0 using integer argument, what would be the first thing that you think of? Just the problem, not thinking about the solution, but what will be your first thought process when you think about the question?
It can't really no.
I can't hear you, Horizon.
that a number that isn't 0 can't sum up to 0?
A number that what?
I am confused on the question.
Okay.
Okay,
Now-
I would say you just have to think of the first step would be to think of which set of numbers will sum up to 0.
Yes, that
I honestly cannot think of any number which something. Unless I'm thinking about it the wrong way.
you're thinking about it in the right way, but you have to think about it deeper. There are numbers. So the question says
Negative numbers you refer to.
perfect. You have the perfect answer. Exactly. The first thing you think about is that there are no positive integers that will sum up to 0, but you have negative integers that will turn up to 0. That is the perfect way to think about it. Sometimes in your job interview, you will not be asked to solve the question. They'll just ask you your thought process. That alone is a stage in an interview. And sometimes, most of the time, in software engineering interviews, you have 5 stages. The first qualifying stage, you see things like this Fibonacci sequence, trying to get your understanding of algorithms. And most time you do the talking. You'll be writing the code and you have to explain what you're writing, right? And you have to think on your feet because you have 5 minutes to solve a thing like this. And they'll tell you that you don't have to have the solution. We just want to hear how you think about it. And what Janelle said is the best solution. When you think about it, there are no positive. So the question never said, don't use negative. Say integers. Integers are both positive and negative numbers. So what you first think of is when you create this array, when you have 1 in the array, you want to have -1. Because you know when you add 1 and -1, it will give you 0. So you always want to have the negative of that positive number. So when you create an array, 0, 1, 2, 3, 4, 5, you want to have the negative values of the same numbers in that array. So you want to start by placing the smallest positive integer, and then you put their negatives into the same array. When you do the smallest positive integer and put their negatives into the same array, it will sum up to 0. Right? Another thing you want to check again is when that number, so let's say you supply an argument n, right? If it is even, if it's an even number, so I don't want to do this assignment for you, but okay, I won't write the code, but I will tell you how to think about it so it will make it easier. So let's write out the algorithm for that. So we create a function, and the function is unique numbers. And we want to put the numbers here, or we put n. Now let's do the algorithm that we use to solve this. Okay. We want to, wait, let me delete this. We want to create this algorithm where we say the first step is to want to think about the numbers. So you start by place the smallest positive integers. And their negatives in the array. Once you do this, this already satisfies it. Okay, at this point, the sum of them is 0. But once you supply this array, if you have 0, 1, 2, 3, 4, 5, you must have negative. So you have, let's say you have 1, 2, 3, 4, 5. You must have -1, -2, -3, -4, -5, which means 10. Which means that at every point, the length of your array must be even. So if you check the length of the array, you must get an even number. So you must have 2, 4, 6, 8. You can't have an odd number in your array. You can't have an odd length. Because if you have an odd length, it means that you will never get the 0 sum. Why? Because let's say you have 1, 2, 3, 4 in your positive integers, and then you have -1, -2, -3, -4, -5. You have 9 items in this array. And so while -1 will cancel 1, -2 will cancel 2, -3 will cancel 3, -4 will cancel 4, what happens to -5? So anytime you have an odd number of items, so the length of your array is odd, it then means that you will never satisfy the requirements. So that's the second thing you think about. Check if the length of n, the number of items in the array, is odd or even. Okay? Whenever it is odd, you want to add something to the array so that their sum remains 0. Now I've already given you all the algorithms to solve it. Now you have to figure out how to put this in the programming language. Does it make sense?
Yes, ma'am.
Okay. All right. So when you want to place items in the array, you want to start from 1, not from 0. Okay. And you want to always make sure that the length of the number of items in the array is equal to an even number. So you know how to use your operators to check if something is odd or even. All right, so let's look at the bubble sort. I think that should have been the most difficult part of the assignment. And I've given you halfway how to think about it. So you just have to code the thought process. When we have a bubble sort algorithm, bubble sort is such that it's like you have a list of numbers, and that list that you have is not sorted. You want to sort this list from lowest to highest. Let's write something called numbers. And numbers is equal to let's have 34, 76, 23, 4, 6, 1, 2. So we have this list of numbers like this. And we want to sort this, but we want to implement the bubble sort algorithm to sort this. The bubble sort is such that it starts from the first one. It compares it with the next one. If the next one is larger, it drops that one and picks up the larger. And then it compares with the next. If it's larger, it keeps going. If the number it compares to is higher, it swaps and keeps going so that it takes that highest one to the end. Then it comes back again and starts again from the beginning and start comparing up until where it has. The sorted part is going to be at the right side and the unsorted part will remain on the left, right? So you don't want it to run through what it has already sorted. So how do you think about the bubble sort algorithm? You want to go through it one value at a time. And then you want to make sure that, first of all, before you start going through, when you go through one value at a time, in the first run, make sure that it's not already sorted, right? And then for each of these values, you compare to the next and take the highest value, swap it to make sure the highest value is the one that keeps going through. And then you continue it until it is completely sorted. When we want to look at how to optimize our code, we think about this in terms of time and space complexity. When we talk about time complexity, we use big O notation. It's a mathematical concept that we use in programming also. And what that does is checks the worst case execution time. Why do we use the worst case? You don't know in advance what values you will have. You don't know in advance how large your data will be. Your software is supposed to run and function for something. You have your non-functional requirements that need execution time, space, and time complexities. When we talk about space complexity, we're talking about the amount of memory that the algorithm requires to execute. and complete its tasks relative to the input size. And when we talk about the time complexity, we are talking about how many iterations of the loop you will need for the execution of that, and what's the worst case that happens. So we look at these algorithms in terms of the worst case. Why do we use worst case? The best case is always good for everyone. The best case is when the algorithm is already sorted, and so you just use n times, just one run to see it sorted. But the worst case is that it is not sorted. All the small numbers are at the end, the large numbers are in front. It has very large numbers, like up to 1,000. And so it's going to have n iterations, n times. So it will be n square, right? Worst case for bubble sort, based on what we have said, it's going to be n square. So when we look at other algorithms in the coming weeks, you want to see their worst case and see which algorithm is better for searching and sorting based on the time complexity. And then you want to look at the space complexity, how many amounts of memory you need to do that. And we'll look at that too in the coming weeks. So in the bubble sort, you want to create the function that will sort these numbers. So we know that we want to start from the first item 0 to the last item. We said that the last item is always 1 less than the length. We want to get the length of the array. So we can say n, let's create the function first, def bubble sort, and we want the array or the list. And we want to get the length, n is equal to the length of the array. When we do the range function, we want to say, we can use a nested loop to say for I in range n minus 1 as the outer loop, and then we have for j in range n minus 1, then minus I. The I now becomes the sorted part. So we want to make sure we are not resorting the sorted part and end up in an infinite loop. So we'll say you can make n equal to length of array minus 1. So you can just say for I in range n. So you can say length is equal to n minus 1. Why? Is that you're just trying to store the index, the last index position here. So now you can say for I in range n, not n minus 1, because you did a minus 1 outside here. So you can always use n. So it makes it neater like this. All right. And so you say for I in range n, and you know that the range function always starts from 0 to n. So if you want like 5 sequence of numbers, so if you say for I in range 5, you get 0, 1, 2, 3, 4. That's 5 numbers. Start from 0, so it ends at 4. So the range will always be like the index position, which is 1 less than the length. Length will always count from 1 to the total. So length will tell you you have 11 items, while the last index position is 10. So for range, you have to subtract 1 from the length. So you make it easy if you do the subtraction in n here, the length of the array minus 1. And so you iterate through saying for I in range n, which is the outer loop, which is going to be the sorted part. So it's going to be the first one that takes care of the right side, which is the sorted. And the inner loop is the one that will run and keep swapping until it gets to the end. So this now checks n minus I. I is the outer loop that holds the sorted part. So you want to subtract the sorted iteration there. And so if you want to check the current iteration, that's the current index position, the item held at the current index position is greater than the one after it. So it's greater than that index position plus 1. Then you want to swap them. And so this is how we swap them. So the item held in that current index position will be swapped with the next, and the one in the next will be swapped with the one in the current. And then at the end, we return the array back, which is sorted. Does everyone understand the logic of the bubble sort?
I got lost in the loop.
Okay, so you know that you can have an infinite loop where when you do it manually, right? What will be the first run? Let's do it manually to see. Manually, you take 34, compare with 76. So let's put this like this. You get 34, compare with 76. 76 is larger, so you drop 34 back, and now 76 is what you are running to. Is it greater than 23? Yes, 23 remains there, 76 keeps going. Greater than 4? Yes, 4 remains, 76 keeps going. Is greater than 6? Yes, 76 keeps going. Greater than 1? Is greater than 23. Is greater than 45. Is greater than 67. Is it greater than 89? No, you drop it now. And then you take 89. 89 greater than 90? No, you drop it and you take 90. And then 90 remains at the end here. Is bubbled. Now this is the first iteration. I remains at 90. The I is going to be this I now is going to be remain here. So the index position for I is that at the end there. That's where it has stopped. I is pointing at this. Now you can't use this I to run this anymore because you need I to point here so it can stop at this index position here. Understand? So this is the first run of the loop where I is pointing the right. So now you need another iterator that will run through all of this. Now, when we say n minus I, what do we mean? The total number of items here minus the total number that is sorted. So I here at this point is just one that is sorted here. Okay, so you take from range n minus I, which means you're saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 minus 1, 10. So it's going to be running from here to here. So it doesn't touch the sorted part, but the inner one. All right. So now when you start the inner one, you know that this is the sorted part already. So this stays on this side. Let's put a long space. Now you take 34. You start in the second iteration. Let's look at how it looks. One of your questions says, how does it look on the second iteration? So you can write a function that will print out everything on every iteration, which is what I want to recode, that will print out what you get on every iteration of the loop, and then the final sorted. So 34 is greater than 23. You swap, you put 23. 34 is greater than 4, greater than 6, greater than 1, greater than 23. Now you see 23 is duplicate, right? Greater than 23, and then use 34 is not greater than 45. You drop 34, and you take 45 is not greater than 67. You drop 45. You take 67 is not greater than 76. You drop 67. You take 76 is not greater than 89. You drop 76. You take 89, and it's gotten to the end. It drops to 89 there. Now I is pointing here, so I is on the second one now. Okay, so I2 is 80, second iteration. So you need this I to keep pointing at the sorted part. So the third iteration now is going to be n minus I, which I now is on 2. Now do you understand?
Yes, it's clear.
Yeah. So sometimes you have to bring it out manually. So when they say what will your algorithm, what will the sorting look like in the second iteration, this is what we need out of the numbers. So bubble sort. So why are we looking at this sorting algorithm? So that when you're dealing with big data and you're writing your code, you need to know what is the best way, the shortest path to get to this. Where will you find something on the tree? What is like? So you have to test your functions to see the way I've written this function. Is it optimized? Is it going to take more execution time? Is it resource intense? Is there a way I can do it that makes it better? That's the whole purpose of all of this, to get you thinking like a problem solver and to create solutions that will be a solution and not become more problems. All right. So when you get to data analysis also, you want to get records in a sequence, a dictionary, a list. How do you sort this record out? How do you do it? If you want to search for something, how do you search? All right, in MySQL, we look at indexes this week, and you see how we use index to optimize our lookup. And so all of these are connected when you start thinking about them in a broad scope. So does anyone have any question?
Yes,
Okay,
can you
ask.
hear me? Yeah, so
I can't hear you.
sorry, I was saying I noticed you mentioned the 23 appearance twice. Before you run your algorithm, does it if you continue doing it manually, it would just appear twice when you actually it would just appear twice, right? Or would it drop over? You mentioned it, but it doesn't say anything about it appearing twice.
Yeah, so once you are doing the sorting, most of the time you want to drop the duplicate, right?
So
And if
when
you don't
you
drop,
run it, it automatically drops it.
yeah, so you might want to just look at, so because one of your question also, I thought about that, and you can see one of the, not the question, one of the, what we handled last in the pre-recorded video is how to remove duplicates from an array, right? And so you want to drop the duplicate to be able to sort, or you can sort it and build it into your algorithm that if it is equal to, continue with the same one. Just drop it, continue with the same one, or don't sort that. So those are complexities you need to think of, and I deliberately left duplicates there, and we actually have it in the pre-recorded video where you remove duplicates for you to think about it like a problem solver and see, removing duplicates, is it better? Do I need to remove the duplicates, or do I need to leave the duplicates there? These are things that you need to think about yourself.
So you're saying that in the upcoming pre-recorded video, you're going to learn how to do all of that.
Oh no, it's already on the week 1 pre-recorded videos on removing the duplicates. So I can actually do it here for you to see. Now, in a list, your list contains duplicates, right? What is the first thing you think about when you want to solve a problem? The thing I always like to think about, and that's why we had the foundational courses of the language, so that you will know the low-level details you need to know. Is there any inbuilt function or inbuilt module in that language that can do this thing easily? And because when it's an inbuilt module or inbuilt language, it's already in the system, so it's actually faster than whatever function you're going to create. So in Python, is there anything inbuilt that will filter duplicates? Is there a function that will remove the duplicate without me creating a loop or something that will look at it and take out the duplicate? Then remember that we did sequence types, I think in week 4 of Python, where we look at the list, the dictionary, the tuple, the set. We know that all of these allow duplicate values except a set, which only allows unique values. There is a way we can convert a list to a set and back to a list just to drop the duplicate. So what do? You can say numbers unique. Will now be equal to, you convert to a list, and in that list you convert to a set numbers. This is one way of doing it, or you can just say is equal to set numbers, and then you convert back to a list on the other line here to say numbers now is equal to list number unique. So you convert it back, convert to set, it drops, convert it back to list. Or we can do it in one, like list set numbers. And this, and so this already drops the duplicate. So this is just the only thing you need that drops all the duplicates. And so now is number unique that holds everything, or you can just leave it as numbers so you can rewrite it. So do you see that? Yeah. So the thinking, you have to remember all the basics. And I told you before in the Python course that if you forget anything in Python, do not forget strings and all those sequence types. Those are very important concepts that we always meet everywhere you go. You always need everywhere. You see, we always use loops also. And we always have to think about inbuilt functions or modules. You want to go through the list to see, is there a module? You don't have to have it in your head. at this point, once you think about it, you have to look for which resource do I look at to find the inbuilt function or inbuilt module that does this job. Okay. So anyone has another question? All right, in the absence of questions, this is where we end this lesson. We're going to go further in the next lesson to look at the other sorting algorithms. For week 2, we are looking at selection and insertion sorts. All right, so your assignment is due, I think, on Monday, and we hope that you will take your time to look deeply and try to solve this on your own, and write out your algorithms of how you think about it and how you come up with your solution. The more you solve is the more you will be able to solve problems that you have never encountered before. All right, so thank you everyone, and see you in next week's lesson.
Thank you.
Thank you.